Hi everyone, welcome to the continuation of the security topic. So that was a great presentation by Thomas. So today we're going to talk about security concepts and complexity that comes with the composable and SaaS solutions. You'd think a lot of things would transfer and it would be about the same, but there's quite a bit of complexity that comes with a composable and a SaaS-based application development, and that complexity needs to be managed. So different things we have to think about. So my goal for this session today is to hopefully teach you a couple things that you can take away with you and use it in your day-to-day business, build more secure solutions. Secondary goal, hopefully I'll get you interested in some of the sites that are around here in Malaga. So we'll start off with covering the basics of security. So if you're new to security, we'll cover off the high-level theory, so you'll know at least where to start after you go through the session. And then we'll take a look at how we would design our applications for increased security. So we'll touch on the network design, network topology, infrastructure. We'll talk a little bit about the coding best practices, and we'll take a quick look at Vercel, some of the things that we can do to improve our security. The information that you'll see in this session is not 100% comprehensive, simply won't fit into 45 minutes. So I'm going to go quick. So please, please, please stay with me. Do ask questions. But the goal here is that this information, if you were to retain this, would help you address about 80 to 90% of security breaches that happen in composable architectures. And then we'll take a quick look at security testing. I'll be referencing quite a bit the session that I did in Budapest last year on DevSecOps. So if you haven't had a chance to see it, do watch it. It's on the YouTube channel, SUGCON. And then we'll bring it all together with a reference diagram. So we'll start with a quick round of intros. My name is Vasily. I'm a VP of Digital Solutions at Altudo. Been in the Sitecore space, gosh, for over 15 years. Been a Sitecore MVP for the past 8 years across all 3 categories, tech, commerce, ambassador. I've been leading Sitecore practices for the past 9 years, and really at heart, I'm passionate about technology, marketing, tech. Lately, I've been spending quite a bit of time in content. XM Cloud is near and dear to me, Azure, and AI. So if you have any questions that you don't get a chance to ask during the presentation here, feel free to shoot me an email to my Altudo email address. I'm also on social, Twitter, LinkedIn. Feel free to reach out at any time, Slack, or simply fill out any of the contact forms on altudo.co or my personal blog, cmsbestpractices.com. So I represent Altudo. As I mentioned, we are Sitecore Platinum Partner. Just a few quick words about who we are, just because I love this slide. We're one of the 6 or 7 global partners who are most badged for Sitecore. And last year we were fortunate enough to get the Delivery Excellence Award and Customer Impact Award. And we have 8 MVPs on staff with us. Alrighty. So we'll start with the introduction to secure technology design. We'll start with a theory. So if you're just starting off, here are the things that you want to consider. The foundational layers of security start with the education. When we think about security in the Sitecore space and development world, we tend to jump directly to automation. We talk about static security scans. We talk about dynamic security scans, various types of scanning on the network and so forth. But really, where we have to start is with education. And you guys being here are already taking that step. So if you're curious about security, and it is a fun topic, as if you saw, Thomas was presenting some cool things. That just got me pumped listening to it. So if you find yourself getting excited about those things, do research. There's plenty of material out there on security, plenty of online courses, instructor-led courses. You can do peer programming. What we do is lunch and learns at Altudo, where we share the latest information, the latest platforms, the latest technologies. So plenty of information there. Do hold off on going to automation, because then you have to learn about security design. Security design doesn't necessarily have to do with designing your application. There's a whole spectrum of things you got to consider. People, first and foremost. You got to make sure you have the right people in the right roles, the right teams, processes, systems, and only then you want to start looking at how to secure your application. So as a developer, of course, for instance, your scope of concern is only going to be focused on developing the application. But if you're leading a team, if you're an architect or a tech lead or a project manager, a director of some sort, you want to make sure that all these things are in place. And only then you want to start thinking about automation. So notice this is the last step. And this is the last step for a reason, because if you don't go through the previous two steps, all you're doing is just automating bad stuff, right? So automating the pain. So in this session, what we'll do is we'll talk about the best practices on networking coding, and then we'll take a quick look at automation, how we can test for our security. So as we talked about in the DevSecOps session last year in Budapest, there are three foundational pillars in security. And when we talk about security, whether it's composable or standard monolith, security in general is based on three pillars. They're called CIA. C stands for confidentiality. So this is the right people have the right access, having the right access to the right data and the right systems. And also systems having the right access to the right data and other right systems. Right? So all these things have to be controlled. Integrity. We want to make sure that our data stays intact at rest and during the transition. That our systems behave in the way they should behave. Right? And then finally, availability. And this is an interesting one. I don't see that mentioned in the scope of security quite a bit, but the availability is one of the main pillars. And what that means is now we're bringing, because we're concerned with the system SLA, we're bringing performance testing, some of the performance testing, into scope of security. So we're bringing things like longevity testing, stress testing, load testing into the scope of security hardening. Okay? So how does the composable picture change things? Well, with a composable, the premise of composable means that our systems have to be agile and resilient enough to withstand changes. So we should be able to replace a system at any point in time without impacting the rest of the MarTech stack, right? So that's the promise of composability. It's not so much about best of breed as you may hear. Gartner defines it, which Gartner defined the term composable. Composability is the ability to replace systems and be resilient, be agile. So what does that mean? Well, we're breaking up our monoliths in multiple moving pieces. So instead of everything living on a Sitecore instance, or a lot of things living on the Sitecore instance, like scheduled jobs, APIs, other capabilities, like search, for instance, those things are now split into separate pieces. And all those pieces have to communicate with each other. So all of a sudden, networking security becomes a big factor. Okay? So as we look at the CIA high level, zooming in, what we need to start thinking about is the OSI model. If you've never dealt with an OSI model, this is an Open Systems Interconnection, that's what OSI stands for, model that's been used for years to describe how communication happens across systems, across different layers. So every request that leaves your application and goes out to another application goes through these 7 layers, top down, and when it enters another system, it goes bottom up. Okay? So let's quickly take a look at it, because this is an important point, and this is how we should be thinking about security. Every single layer in the OSI stack needs to be considered from the confidentiality, integrity, and availability perspective. Now, all of a sudden, things are starting to get more complex, right? So what are these layers? Well, application is what we write as developers, right? This is the system that we create, and as Thomas pointed out, rightly so, there are plenty of exploits out there, right? So when we talk about exploits, these are worms, viruses, backdoors, simple coding errors, right? The ability to do injections. These are ultimately application weaknesses, okay, that can be exploited. Once the application creates the request, it then gets passed on to the presentation layer. This is the layer where data gets serialized. This is where it gets encrypted. At the next layer, session layer, we're starting to look at session management. So this is the layer that's responsible for creating, terminating sessions, and also port management. With the transport layer then taking on TCP and UDP protocols. This is where we're starting to look at the transmission. So some of the threats that we're starting to see on the right side here, right, that have to do with eavesdropping, SYN flooding, that's a popular one. Sniffing, port scanning is an interesting one. But on the couple layers above with session hijacking, that could be a real problem. networking layer, we start looking at IP routing. This is where we start routing our messages, right? This is where the IP address comes into play. And the threats that we see at this layer are the famous ones, man-in-the-middle attack, right? Or denial of service attacks, right? So the denial of service attack actually can be performed at multiple layers, and it uses what's called an asymmetric principle based on the fact that it takes more time to process the request than to execute the request, right? So we're basically overpowering the system, and that can be done at multiple layers. Data link. So this is one that's often overlooked. This is where we start breaking out. If you're into networking, you know we're starting to break out the packet into frames. So your packet gets split up into chunks. The chunk has frames with special metadata that then gets put on the wire, right? This is where our MAC addresses live for local routing. Switches use that. So some of the threats, common threats that we see here: MAC ARP table spoofing, MAC flooding, VLAN hopping, and finally, and this is really an often overlooked layer, the physical layer. So from the networking perspective, that deals with physical connections, cables, access to the system, for instance, right? From the security perspective, simply having physical access to things. Okay? And that could be anything. That could be having access to someone's system that's been left open, having access to being able to unplug a cable from the wall, or simply having access to just walk up to someone's machine and plug in a USB, right? I actually recently was cleaning out my OneNote. I use OneNote for note-taking, and the notepad that I was using got corrupted and it wasn't syncing with the cloud, so I had created a new one and I was transferring notes over. I noticed from the notes from years ago, probably 5 or 6 years ago, I had login information that I wrote down quickly on one of the projects. And I was like, oh, I wonder if that still works. Plugged it in, I was able to log in. That was 5, 6 years later. I was able to log into the internal system of a client that I was on a project for, and I had admin rights to it still. So think about the things, you know, that we mentioned at the physical layer. Think outside the box of that one. What could happen, right? Think about the black swans. So now, as I mentioned previously, when the request comes in, it goes up through the layers all the way to the application layer, and when the application sends the request out, we're moving down, right? So now we can start imagining how much there is to security, because we have to secure each layer, how things happen at each layer, right? And what's good in a way is that a lot of these things are taken care of for us when we move to the cloud, right? So Azure, AWS, they take care of some of these things at the lower levels, right? Securing the lower levels. So when we look at the composable architectures, we're really, for the most part, looking at layer 3 through 7, right? From networking to the application layer. Now, quick housekeeping item. I know I like to take screenshots of slides, and what I've done in this presentation is I put a little camera icon in the top right corner, because what I find myself doing is taking maybe 20 pictures of the slide as the animations go through, and then I have to go clean that up. So just a quick tip: if you guys do take pictures, just wait for that icon to come on. That means there's no more animation. You can take a picture of the slide. Okay? And I've also put it on the slides that I think are most important. So how does that change with the composable world, right? Again, where's the added complexity? Well, let's look at what changes as we go composable, as we go SaaS, right? So here's where we are now. We have, let's say, an XP0 setup here, oversimplified, right? Let's say we have Sitecore running on the VM that calls the database. So what we're working with here is a couple of OSI model stacks, right, that we have to secure, a couple systems. So the attack surface is relatively small. Like, all we have to worry about is a couple systems in this case. What happens with SaaS? What happens when we go to XM Cloud? What happens to the jobs, scheduled jobs? What happens to the APIs that we have living on XM Cloud? What happens to heavy processing that we might be performing on XP? That can't go to XM Cloud anymore. That has to go somewhere. And if we follow the separation concerns principles, we do right, we separate that into separate endpoints, right? We start implementing the service-based architecture. What does that mean from the attack surface perspective. All of a sudden, we went from, let's say, a couple of points of concern to 16. We split up our jobs. Let's say we created 3 functions to do our jobs, 4 functions to do external 5 APIs. Those would have their own databases and may even have their own head with Vercel on top of that. So you can now see with composable how quickly things can blow up, like exponentially. Now the attack surface has increased massively. Now we have to ensure that all these systems are secure. So the job of CISO has increased dramatically. The complexity that comes into play, and this is a simple scenario, right? We're talking about a handful of services here. We'll see what things look like once we actually get into enterprise microservice implementations. That becomes a lot more complex. So now that we understand the complexity that comes with it, right? The complexity of managing such a vast attack surface. And with complexities comes the cost. So how do we mitigate the cost? How do we bring that down? What are the things that we can do to still manage security across our solutions? So let's take a look at some specific things that we can do within a service-oriented architecture. So this is an example of a simple setup. What we have here is we have a client trying to make a couple of calls to a couple of internal resources. So let's say we have a microservices layer potentially running on the AKS cloud, and then we have an endpoint that runs on a function. So what we have here in this topology, we have the request going through the front door, and I'll walk you through how that happens. We have an Active Directory that stores all the information for the user login information. We have an API management node here that controls the routing and handles authorization in addition to many other things. We have a private endpoint that's connected to the function, and we have an AKS cluster. And all those 3 applications are wrapped in a virtual network. So let's talk about how requests travel here. So first we have a client that needs to make the request, right? So that client, that request is going to need to go through the front door. So all of our requests have to be put through some kind of firewall, first and foremost, right? Azure, we're talking Azure language here, but similar concepts apply in AWS as well. Front door has a WAF built into it. Well, that means by default it blocks all traffic except for HTTP and HTTPS. In addition, it has some rules, some bot protection rules. So we have to put all the requests through that layer, right? So only valid requests, or requests that front door deems as non-malicious, at least front door is not the answer to everything, but at least we're filtering some riffraff, some noise right out of the gate, right? So once the request passes through the front door, it hits the API management. Well, API management is responsible for authorizations. In our case, what we want to do is authorize the system and the client. We want to make sure that the request is coming from the right system, and it's also coming from the user or the client that's authorized to make those requests. Right? So we have to do it at both levels. So to do it at the system level, we can create what's called an NDS, NSG, Network Security Group. So we can add a subnet around it. Front door adds a header to the request that would allow API management to validate that the request is coming from the front door. Okay? However, when API management looks at authorizing the client, it's not going to see the token the first time around, right? So what it's going to do, it's going to kick that request back, send that back through the front door, saying that this requires authentication. So if we're working with a web app, this is where, let's say, the client could get a pop-up, for instance. Or if we're working with a human, could get a pop-up to authenticate through a single sign-on, for instance, right? So let's say they authenticate, and what that does is it then passes the token through the front door back to the API management. Now, API management looks at the token, and JWT is kind of the gold standard for authorization these days, right? So don't reinvent the wheel. Use JWT. Okay. API management is going to look at the token, and then it's going to go back through the front door again, the same route to validate it. Once it's validated, then only then it'll pass on the request to the backend systems. Okay. So the request to AKS, pretty straightforward. It's within the VLAN. It's relatively secure. Now we're working with the private IPs. We have a relatively safe expectations for things being safe there. However, how do we secure PaaS appliances? Right? Platform as a service, web apps, functions, those are public by default. One of the easiest way to do that is through the private link. So we would put the private endpoint within our VLAN, okay? And then we configure the function to only accept calls from that private endpoint. So the function itself doesn't need to be, well, can't be in the VLAN, right? But the fact that it can only accept calls from the private endpoint, by default, will disable access from everywhere else. So if someone tries to access the function directly, they won't be able to. Requests will be denied. Same thing, they won't be able to get to the AKS because it's not available publicly. There's no public access. They have to go through that front door, right? Now, that takes care of confidentiality, relatively, and integrity. For availability, some things that we can also add to this is an application gateway between the front door and the API management. And the reason for that is front door will still forward bad URLs, right? So front door doesn't do URL-based routing. So if someone just tries to send a bunch of API requests with bad URLs in it, it's going to let it through, right? If it fits within the rate limit, right? So there's still a way to sneak some stuff in. There is a way around that. You could create a routing rule and route those requests somewhere else. Potentially a better way would be to implement an application gateway, use URL routing, and only allow certain URLs to pass through certain formats. Everything else can be pushed to sync pull to the dead end. Just simply gets discarded. So that way we're not passing that load back to the back end, right? And if we're talking about a mission critical system, obviously for availability we need to have another region. So we would replicate this same setup in a separate region. Okay? So.
Can you clarify for a moment the app gateway? Like, what extra defense does it add compared to front door? Sorry.
What it does compared to front door?
Yeah, I mean, I know the app gateway, but I don't understand how does the app gateway protect more than front door in this case?
So the app gateway is doing multiple things. So front door is, has some bot protection. Then it has automated filtering enabled. Allows you to do manual filtering of rules based on geo, based on various factors, right? Then there's dimension bot protection. So there's a firewall that's built into it. It can also act as a global traffic manager. So in this case, let's say if we're routing to a different region. From the load balancing perspective. Now, API management is slightly different. So API does, so in this case, does token validation. Right? So it does authorization. SSL, certificate validation, it can do IP restricting, and it can also do routing for services, I think. Rate limiting, that's another feature. And I think it also does have some request validation functionality built into it. So it has a bit of an overlap. But for the most part, here the main function of the API management from the security perspective is authorization token validation. So client authorization. Okay? So this is pretty simple. This is a service-based architecture. We're not doing a whole lot here. Things get a lot more complex when we start taking that and trying to turn that into a composable architecture. Right? So what we see here is what's called a point-to-point integration. We have a client calling the data source directly. Right? That goes against the composability principle. We should be able to replace the data source without having to impact the client. In this case, we would have to rebuild the entire integration, so it does affect the client. So in the case of composable, we're now looking at introducing a new layer. There's nothing new, an abstraction layer, an API services layer. Right? So that abstracts the backend systems away from the client. So the client communicates with the API layer communicates with the data source. Also, APIs communicate with each other. Okay? So from confidentiality perspective, client to service communication is pretty straightforward. TLS, encryption, certificate verification is there. From service to service perspective, things start looking more interesting. So traditionally, we've used what's called a mutual TLS to authenticate services with each other, to develop the trust between the services. That's been around for a while, The big problem with that is, one, if an intruder were to get access to any of the APIs, then they would also be able to call the services that the API has already created trust with using certificates, right? So that's not good. So things have been moving towards what's now called zero trust, okay? And the premise of that is none of these systems trust each other, right? No matter whether they had communicated in the past or not, every request has to be checked and validated. That sounds like a good idea until we start looking at microservices and massive amounts of services with enterprise setups. Now think about every single endpoint now has to perform multiple functions, every single API. Not only has to do what it was built to do, let's say call the data source, it also has to deal with certificate management. It also has to do with security, authorization, routing rules, has to do its own logging. And imagine having to trace the request as it goes through the microservices architecture, as it jumps back and forth and bounces between the APIs. Good luck tracing that through the logs, right? And trying to figure out how the request went around the system, especially if you're working with hundreds of services, microservice architecture. So, to solve that, mesh services architecture came into play, okay? Service mesh. And there are a couple concepts. We're not going to go too deep into it. My goal is to at least familiarize you guys at a high level with what that looks like and why it's important to consider so you can go and research that further, right? So when you are working with composable systems, with especially microservices, this becomes a crucial point because otherwise maintenance will be a nightmare. Imagine having to update certificates, enforce certificate expiration, and having to update that on hundreds of APIs, right? So that just doesn't scale. So the solution to that is service mesh. There are two concepts you want to be aware of. There is north-south protection for the service mesh. That's where we're concerned with allowing or disallowing traffic in or out of the service mesh, okay? And then there's east to west. And this is where we're dealing with securing individual endpoints and the communication between the individual microservices. So service mesh is based on a couple of planes. There's a data plane, that's where our services live. And there's a control plane. This is where all of that overhead that we had to do is exported out into. So some of the main or perhaps common components are certificate management, authorization policy, logging, monitoring, and routing rules. All that's taken care of by the control plane, okay? Now, each microservice, once it's deployed to the open service mesh here, in this case, this is what we're using for the example, would get what's called a site card attached to it. It's a proxy. That then communicates with a control pane and manages all of these aspects. Logging, security, authorization, and routing rules, right? So this is how we can now scale without having to incur additional overhead. So that's where service mesh architecture comes into play, okay? So now we know at a high level what we need to do and when on the networking level. So how do we secure our APIs, the actual microservices that we develop? Well, for that one, let's look at the OWASP top 10. Okay? Top 10 for APIs specifically. We've probably all heard about OWASP top 10 in general for web application development. They have quite a few lists there. Web is just one of them. They also have cheat sheets for logging, for security, so do go through their website. I encourage you to visit it. That QR code will take you directly to the top 10 list, but look around. There's a lot more there. So the top vulnerability is broken object level authorization. This seems like a pretty straightforward one. Simply make sure that the client has the right authorization level, is authorized to execute the function that the client is trying to execute. Seems pretty straightforward. Let's take a simple example. Let's say we have a form on the website, right? That passes the data to an endpoint, then the endpoint simply saves it in the database, right? What do we usually do? Endpoint would probably have some kind of credential saved for SQL connection, right? That will give it access to, write access to the database. We don't actually restrict table level access, do we? So if we got clever enough and there is no validation in the injection, we could inject a SQL query that could modify a different table in the database. So that's a simple example, right? But these are the things that we don't normally think about. Broken user authentication. Anything under the sun about weak passwords, credentials being transferred in clear text, right? The things that we can do here to protect that. Implement the TLS, right? And implement multi-factor authentication. Interestingly enough, multi-factor authentication reduces breaches by 99.99%. So if you can, do implement the MFA. Excessive data exposure. This is where our APIs just become too chatty, where we expose too much data. In fact, Sitecore XM Cloud exposes just a little too much data through the edge, and we have little control over that. So one of the things that you would perhaps want to do is, in Vercel, trim some of that data out. With the edge, we're sending out all of the advanced fields, all the information from the advanced fields, not just, there's no way to control that as of yet. So keep that in mind. This is an example of those things. So what we want to do is make sure that we're not exposing any sensitive data in addition to basic properties. Lack of, and that actually is relatively straightforward to do, especially in Vercel, through creating an additional layer with whitelisting or blacklisting of the properties. Lack of resources and rate limiting. This is perhaps due to developer laziness for lack of validation. It's so easy to simply build an endpoint that accepts an array of objects and then just pass it on to the backend for processing, right? So for our web application, it could be a simple scenario. Let's say we're looking for an array, 2 or 3 objects that could be passed on from the client. What we don't do is we don't actually check if it's 2 or 3 that are coming in. So if I were to gain access to that API, what if I submitted 1 million? What happens then? What if I submitted 1 million and attached a video to it? What are we doing with the processing, right? So we're not doing proper validation. This is the result of the rate limiting vulnerability. So do the validation. In fact, validation is probably one of the most important things that we can do as developers to secure our systems. Validate for size, validate for content format, right? And validate for the rate. Okay, those are perhaps the 3 most important ones. Broken function level authorization, similar to object level authorization, easily fixable with attributes. Make sure that we have, the clients have the right access to the right functions. Mass assignment, that's interesting. That's also perhaps due to developer laziness, is where it's just so easy to serialize and deserialize these days, right? So we take input from the client, we take it from the client application, we take it for granted and pass it on to the back end. Give you a simple example. Let's say an update form for an email, right? So there would be a text box, the user would enter their email address, click save. What happens then? We'll probably have some unique identifier that we attach to that email, kick that back to the back end, right? So, and the user with that unique ID gets updated, right, with that email. Well, what if I were to brute force and guess the user ID? Could I update someone else's email that way? Right? So we want to make sure that we're not letting the client application update sensitive properties here. And that's also, again, easily done with an additional layer on top of it. Security misconfiguration. There's so much here. That list doesn't do it justice. Anything from hardware to software to network, security misconfiguration is a big concern. Some of the perhaps most popular ones are cores and lack of hardening in general. In Sitecore, I hope everyone follows Sitecore hardening rules for their XP implementations. Injection, you'd think this would go away by now. Still there, hanging in. This is where we're able to inject instructions, right? We actually just saw that with deserialization example, right? We injected an instruction to run the calculator in the previous session. Thomas showed us. Improper asset management. Assets refers to things like APIs, networking assets. It could be APIs, hardware, appliances, so forth, just left unattended, undocumented. For instance, to give you an example, let's say we're developing a new version of the API. We leave the old version there because we still show some traffic going to it. And the old version, unfortunately, doesn't have a whole lot of documentation on it. It's also statistically, 1 of your 5 to 7 coworkers is going to leave this year. And what you want is capture and document that application as much as possible, because what could happen is you could very quickly end up in a situation where you have a brand new team in a few years and no one knows what that application does, what that endpoint does, what that appliance does. They're afraid to touch it. They don't know it. It doesn't consume a whole lot of resources just sitting there. Why not leave it, right? That becomes a huge security hole. So especially with those V1, V2 patterns, right? Just switch it back to increment that by 1 and you'll probably guess the URL for the old service. Insufficient logging and monitoring. So one of the most important things is you want to ensure that you have observability in your application. You want to make sure that you can capture a state of the application at any point in time and also trace requests as they go through your application. Cloud Defender helps with that. Azure monitoring, basic tools, basic insights, right? Implement NIDS, network intrusion detection systems. So all of these things will come into play. So that covers off at a high level the top 10 on the API. So what can we do at Vercel? Vercel's pretty interesting. I remember when I first heard about it, I was like, well, it's just a CDN. But it's a lot more than CDN. It is a platform on which we can run code. And with that, now we have vulnerabilities, right? So everything that applies to API or WASP Top 10 also applies to Vercel, because we can run serverless functions. We can create endpoints on Vercel. So everything that we just talked about applies here. Additionally, use Vercel security. Restrict access to non-production environments. Vercel authentication comes by default with all subscriptions. The only limitation here is that you have to have a Vercel account to log in, I think. And then if you don't like that, you can opt in for password protection feature that comes free with Enterprise. It's $150 a month additional if you're not on the Enterprise subscription. So that way you don't have to have a Vercel account. Do not store secrets in code. This is such a common one, but what's happening now, and I'm seeing this firsthand, is front-end developers are now developing what used to be back-end developers' domain, the functionality that used to be in the back-end. So front-end developers because of their nature, aren't used to dealing with a lot of security, right? So it's not to their fault. They're just, there are a lot of things that are coming into their domain now that you used to not be there, right? You're developing middleware, you're developing APIs all through JavaScript, right, essentially. So now front-end developers have to get educated. So I see this myself as secrets are being just stored in code, because front-end developers are used to working with secrets that are not sensitive. So it's not to their fault that they're just taking the default approach. Trim sensitive properties passed from the backend. So this is the one I was talking about with XM Cloud. So XM Cloud will pass on some things we may not want to pass through further. In terms of availability, use edge caching. So Vercel functions allow us to do edge caching. So this will help us offload the backend a little bit. Configure cores. These are endpoints, remember? We can create APIs similar to a traditional API. We want to make sure we tighten up our cores. We don't just allow any domain to call our services. And perhaps one of the most important ones, use logging. Vercel has its own default logging configured. However, do log as much as you can on the front end using console.log. So that's going to write log into Vercel's log. And reference OWASP logging cheat sheet. That has the standard for logging for security purposes. Needless to say, TLS. And I'm looking forward to Vercel starting to support HTTP3, what they talked about in the presentation, because that's going to speed up and secure a lot of things here. So, now I'm not going to focus a whole lot here on automating and testing security. There's a lot to talk about on the DevSecOps side. One of the things that I do want to point out is that with the advancement of composability, now we're starting to find ourselves amongst what are called polyglot applications. Polyglot applications use what's called a service domain service language, DSL and DLS, that basically stands for picking the right language for the right implementation, right? So for certain things, it's best to use, for instance, PHP. For others, .NET Core. For others, JavaScript and Python for machine learning, on and on and on. So what we end up with a collection of services that use different stacks. We need to use different tools to orchestrate the CI/CD. And good luck managing security across all of that, right? So it becomes unbelievably complex and hard exponentially. I mean, we talked about the complexity of composable to begin with. Now we're introducing a whole new layer of complexity. There are reasons why this is growing. There are good reasons. But do consider this when you run into it carefully, the total cost of ownership, because the governance will go through the roof. Security specialist costs will go exponentially through the roof. Now we're talking about a security person per stack. Right? New tools, new platforms. We can no longer centralize our CI/CD templates. We can no longer use the same infrastructure. Everything. You're going to need to have specialists, security specialists in all these areas. So as much as you can, avoid it. There are good things about it. However, consider it carefully. Another thing that this would affect is your team structure. In the DevOps session, we talked about structuring, creating a shared team across projects to gain efficiencies, a shared security team, instead of including an individual, a dedicated, or appointing a dedicated security champion or evangelist within a team, because that doesn't scale. Well, we're going to have to go back to the non-scaling model with polyglot applications. So that's another problem. Another thing that we looked at last year is the testing pyramid. So I'm not going to go through all these tests. If you're curious to learn more about these tests, do watch, again, keep referencing it. Do watch the DevSecOps sections from last year, where I cover in detail each one of these tests. But one thing that you do want to make sure is keep in mind that security is a cost-benefit exercise. So we have only so many dollars to spend on mitigating security. Right? At a certain point, it just costs more to mitigate a security risk than to simply accept it. Accept the loss if it were to happen. So what we want to do is, one, create a testing strategy that provides the most coverage for the lowest cost. Move testing as close as possible to code commits. Fail fast. Okay? And then manual testing. Seems like it's a thing of the past. It's not. As much as we would like to automate everything, we simply just not cost effective to automate everything. There are complex use cases that are too complex to automate. Too costly to automate, right? So this is where we would still need to take advantage of the pen testing. Okay, manual testing that's where we test for those outliers. Okay, so let's bring this all together into a single slide reference diagram, something that you can take with you, research, look at it later, research some of the concepts. There's some things on here that I haven't talked about, but I did mention on the slide. So we know we've talked about the CIA principles, the pillars. We know we have to start with education. We talked about the OSI model layers and the things that we can do to help protect those layers. Some of the basic ones: physical layer, turn off your computer, log out, secure passwords, don't put them on sticky notes, please. Check system for rogue peripherals. How many of you, when you sit down at your computer, check if there's a USB key inserted? We used to play jokes on each other all the time. There are USB keys you can purchase, I think, on eBay. You plug it in, and it's not very obvious in what it does, but once in a while, just do something that just makes you wonder that you're seeing things. And it just starts just slowly just messing with you. I mean, it's a harmless prank, but imagine if that was a virus, right? Data link layer, restrict traffic from within VLANs, use private links. Network layer, front door. In fact, everything from layer 3 and up, front door can help protect in some shape or form. Implement Azure Front Door to protect the transport layer as well with TLS, encryption, make sure data is encrypted in transit and in store. Session layer, implement Azure Front Door, rate limiting here. Implement Azure Front Door to protect the presentation layer. Encryption and application layer, there's just a whole lot of things that we can do that we've already talked about. Now, once we build this, again, we have to document. Once we've documented, we need to make sure that we have proper monitoring in place. Observability is a huge factor. And finally, testing and automation. Only then we need to start testing and automating, because if it hasn't been tested, It simply doesn't exist. Cannot be relied on, okay? No matter how well we follow the rules. So hopefully there were a few things you learned and can take with you now and start changing the way you work, the team dynamics, the way you build applications. And with all that said, there's one more thing I want to mention, and it's this. Most security breaches happen from within organizations. So on that note, thank you very much for your time.